All right, guys, can you hear me now? If you can give me a green check if I'm on. I see Chloe typing things. Sound working. Work now, getting some green checks, perfect. Sorry, we just missed a setting there. But we're good to go now. Wait, now I have sound, good, Damon, good, excellent. So everybody seems to be giving me green checks and hearing us now, which is great. I was just saying, I hope you guys had a good time with Mr. Jennings this morning. Mr. Jennings and I actually went to high school together. We've been friends since grade 6, I think, maybe grade 5. We've known each other for a long time. We've hiked together and vacationed together, and our kids are the same age. Just waiting on a few more checks. We're going to get going with any questions you had from last day. The learning guide section and question number, or page and question number would work. Maybe section might be a little bit easier. Looks like most of you guys have put in green checks, so looks like we're all ready to go. And then once I go through any questions you guys have, that kind of ends Unit 1. So we will then move on to Unit 3. And the beginning of Unit 3 is actually a review of grade 9 stuff. So pretty straightforward things. Just maybe a bit of a refresher. So I see a couple of people typing. If you do have any questions, you want to put those in. Just looking at the course while you guys are entering those questions. So we finished lesson 4 and 5 last day. And Avery doesn't have sound still. I think everybody else seems to be doing okay with the audio. Looks like a few of you might not have it. You might run the audio setup wizard, or if that doesn't work, then you close down and open again, but you don't have sound, so you can hear that. So I'm just going to type it into chat. All right, so hopefully that helps. We're audio probleming again. We're good? All right, technical difficulties this morning. Hopefully you can get in with that. Anyways, Ava has a few questions about multiplying, dividing radicals, so we can do that. And if anybody else wants to throw some questions in, as I was just mentioning, in terms of the course, you guys have finished all of the lessons. All the information has been kind of delivered in terms of my end of things here. I noticed that a lot of you guys have written the quiz number 1, which was really good. And quiz number 2 after today. Hopefully you can get a chance to do that. I was hoping you guys might have some time to finish your work today and get your learning guide in for Unit 1 by tomorrow at some point, and then I can get you guys the code for the test either tomorrow or Thursday, and then you can write it between tomorrow and Friday's class. So that's kind of my hope, keeping everything kind of on track. Like I was saying, today's material is a review of the grade 9 stuff that you guys learned last year. So nice kind of easy start to things. You shouldn't have terrible difficulties with it. Avery, how are we doing? Sign back in. I'm just gonna type so figure out if she can hear me or not. And clear out these check marks. Just want to make sure everybody's good to go. No. I'm just going to leave her a little message here.
Refresh.
Avery just signed out and then signed back in. I guess it's her computer. All right. Hopefully, if we can get that sorted. Maybe try signing out and in again, and we'll see where that goes. You know what I didn't even open Unit 3 yet, or give you guys the printouts for that, so that was kind of silly of me. I'll do that right now. I'll open up the unit. I made all those sheets in my office, and I don't know if I uploaded them or not yet. Let's have a look. Learning guides there, exponent law sheet. I didn't put the sheet in there yet. So let's go through the unit Unit 1 learning guide questions that we did. Yeah, Taylor asked a good question. Can do it in 2 big files again. Sure, I'll put all the lessons together, and then I'll put the learning guide together. Learning guide's always 1 big file, but the lessons I'll put together in the big file as well, so you can just print them all off in one go. Maybe I'll go through a few questions from Unit 1 and then maybe take like a 5-minute break, and I'll get that stuff all uploaded to the course so you guys can maybe even just print off the first part and then have something to go through for today. I apologize for not doing that sooner. So a few questions that I kind of have missed now. I'm just gonna scroll up here on my other page. Multiplying and dividing radicals 1, F, 4b, and 5b. Multiplying and dividing 1f, 4b, and 5b. I'm thinking multiplying and dividing radicals number 4 doesn't have a part B, and 5 doesn't have a part B, so I'm not sure what's going on there. Ava, if you want to maybe clarify that while I'm doing this one. Letter F. So, looking at this guy, I need to figure out if there's any sort of simplification I can do before I do my multiplication. So is there anything under the radicals that's a perfect square? Just maybe make my life a little bit easier. I'm going to just jump up to the top here and rewrite the question. So I have 3 root 2 times 4 root 10, and that is times 5 root 50. What I'm going to do is break down this root 50 because I notice there's a perfect square that goes into here. So I'm going to break that one down. 3 root 2, 4 root 10. I'm going to have 5, and I'm going to break down the 50 into 25 times 2. Do you have to do it this way? No, you definitely don't, but I'm just choosing to do it this way. So 3 root 2, 4 root 10, 5. I get this root 25 is going to give me another 5, and then root 2. So 3 root 2, 4 root 10, 25 root 2. All right, so now I've simplified that radical, I can start my multiplication. So I'm going to just do the first 2, and then I'll do the third one next. So 3 times 4 gives me 12 out front, and then 2 times 10 gives me 20. And then I'm just going to drop the 25 root 2 down. 25 and 12, I don't know what that is. 300. And then 20 and 2 gives me root 40. So at this point, I've done my multiplication, and I just need to simplify my radical. What is a perfect square that goes into 40? So I have thinking, I know 4 goes into 40. Is that the largest one? 4 and 10. There's nothing that goes into 10 that's a perfect square, so that is the largest perfect square that goes in there. So I'm going to break my 40 down into 4 times 10, because 4 is a perfect square. And then I'm going to take the square root of the 4 to get 2 root 10. square root of 4, and then 2 times 300 is 600 root 10. Now, it's important to show as many steps as possible. If you're really confident with these things and you really know what's going on, if you skip a few of the steps along the way, kind of like, well, I'm not going to encourage you to skip steps, but if you've done it in fewer steps than I did it, and I can follow your work still, I'm going to be happy with that. So that was 1F. That was a bit of work there. 4B, 5B, multiplying, dividing radicals. I'm not sure what that is. Sign out, Avery, okay. Question number 1, adding, subtracting radicals. Oh, 4B and 5B are perimeters. Thank you, Ava. Alex asking a question about showing work in that small of space. Do your best. If you need to attach another piece of paper on the side, that's fine. I'll understand. If you can fit it in there, perfect. If you can't, then do it on the side. And then just kind of tack it onto the back and just write down the question number, and I should be able to follow. Avery out again, not back in quite yet. We're gonna do the perimeters and then adding and subtracting radicals, Alex's question. So let's look at a couple of these guys. So B, the perimeter, I didn't see that before. I apologize. So this is 4B. The perimeter is going to be the outside added together. So if I have the 3 root 2 there, plus the 2 root 3, I also have the 3 root 2 plus 2 root 3 down here, and I have a 4 root 2 on this side. So what I can do is just add them all together, or I can multiply and then add. Maybe I'll just add them all together. So I'm going to take 4 root 2 plus 4 root 2 plus 3 root 2 plus 2 root 3. This is, maybe I'll color code it. I have 2 of these guys, so there's one of them. And then I'm going to add another one, 3 root 2 plus 2 root 3. There's my second one. And then I have 2 of these guys, 4 root 2, 4 root 2. There's 4 root 2, 4 root 2. So I've added all 4 sides together. And now I just need to combine like terms. So I have 4 root 2's, I have another 4 root 2's, I have 3 root 2's, and another 3 root 2's. So how many root 2's do I have all together? 4 plus 4 is 8, plus 3 is 11, plus another 3 is 14. So I have 14 root 2. And then I have root 3's. I have 2 root 3 and another 2 root 3. So how many root 3's do I have? I should have 4 root 3's. Is that all of them? I think it is. So that would be the perimeter of that guy. Does that help you out a little bit, Abby? Or Ava? That was Ava's question, sorry. Hopefully that makes sense. So you just take all of the sides and just add them all together. 5B is going to be a similar question, I imagine. Find the simplified expression for the area and the perimeter. This is a little bit trickier because we have to do a Pythagorean theorem type question to figure out the length of this side. Maybe I'll call it x. So if I have a right triangle here, 1 side, 2 sides, 3 sides, I know the back, I know the bottom, or half of that, and I have this x that I don't know. So I'm just going to redraw the triangle right here. Not a very good right angle. Try that again. Tricky question. So the whole distance along the bottom is 4 root 2. If I am just dealing with this little piece here, I'm going to divide it in half. So 4 root 2 divided in half, or divided by 2. 4 and 2 gives me 2 root 2. So this bottom bit is 2 root 2. This edge is 5 root 2. And I'm trying to find x so I can get my perimeter. So I'm going to do the Pythagorean theorem over here. So I know a squared plus b squared is c squared. The a and the b don't matter, the c does, and the c is x in this case. So 2 root 2 squared plus 5 root 2 squared equals x squared. So 2 squared is 4. I could write it out as 2 root 2 times 2 root 2 plus 5 root 2 times 5 root 2 equals x squared if I wanted to, and then do the multiplication. So what I'm going to do is 2 times 2 is 4. Root 2 times root 2 gives me root 4. And then 5 times 5 is 25. And root 2 times root 2 gives me root 4. And all this is equal to x squared. And I can take the square root of 4 is 2. So 4 times 2 plus 25 times 2. Again, taking the square root of 4. 8 plus 27 is x squared. And 8 and 27 together give me 35. Getting ahead of myself is x squared. So I get x is equal to the square root of 35 if I take the square root of both sides. And I'm just going to leave it as the square root of 35 for x. Oh, I knew I made an error. Something was wrong. 25 times 2 is not 27, it's 50. There we go. 58 is x squared. And take the square root of both sides. So x is the square root of 58. I thought the whole bottom was 4 root 2. In order to find x, Abby, when we redraw the triangle, we only want half of the base because if you go all the way across the bottom, that's the whole base. But because we've redrawn the triangle to use Pythagorean theorem, we need a triangle with a right angle in it to find that missing side, the kind of the slant of the triangle. So we're going to take half of it because the whole distance across the bottom divided in half is going to get me that far. And the final equation. 2 times 2 is 4, 2 times 2 is 4, so 4 root 4. When we're multiplying these guys here together, we're going to get root 2 times root 2 is root 4. 4 times the square root of 2. 2 and 2 is 4. Square root of that. Have I made an error there, Abby, or is it just something you're trying to kind of wrap your head around right now? We ended up with x was the square root of 58, so the kind of the slants of the triangle. Is anybody, are we clear? Clear on that? Okay, maybe if you just, if you can identify the exact spot that you're confused with, I can maybe help you, or maybe it just be a matter of you kind of looking at it afterwards. All right, once we get there, we need to actually just find the perimeter of this thing. So we're going to have our sides. So we have one x here. We have another x over on the other side here. So we have two x's and then 4 root 2. And we had x was root 58. So if I want the perimeter, I'm going to have root 58 plus root 58 plus 4 root 2. Are there any perfect squares that go into 58? So like thinking 36 doesn't go in there. 58 divided by 4. Nope. 58 divided by 16 maybe. Try my calculator. Nope. So I'm thinking there's no perfect squares that go into 58. So how many root 58s do I have? I have 2 of them. And then I have a 4 root 2 on the end. So that was what I kind of ended up with there. 2 root 58s and a 4 root 2. The order won't matter. You could have 4 root 2 and then 2 root 58. That's fine. Just kind of depends on how you ended up doing the question. See, a few more people have posted a couple questions in here, so let's go have a look at that. Had the 4b, evaluating irrationals. There was one question I think Alex asked. Question 1, adding, subtracting radicals. Maybe have a look at that. What that's all about. Alex, any specific ones? Any specific questions out of adding, subtracting number 1? Maybe we'll pick a hard one here. Something down at the bottom. Bottom half, J. 1E. I like J. Let's do J. All right. Root 27. Perfect squares that go into 27, are there any? Root 28, same question. Minus 300 under the square root. And then minus 12. All right, so thinking. 27 is it's a prime number, so there'll be no factors that go into 27. So 27 is just going to stay root 27, unless you guys can think of a perfect square that goes into there. 28, on the other hand, has a perfect square that goes into it. I know 4 times 7 gives me 28, so I can break that down. How about 300? Perfect squares that go into there. I know 25 goes in 12 times. Is there maybe a bigger one? Let's think here. What are my bigger perfect squares? I have 100 times 3. It's probably the biggest as I'm going to get. And then 12 is going to be 4 times 3. So all I've done is I've just figured out the largest perfect square that's going into these things. The 28 I'm breaking down into the 4 and 7, 300, 100 times 3. The 12 I'm breaking down into 4 times 3. Now I can rewrite the radicals as 2 separate, or I can just take the square root of the first, and that's all I'm going to do. This is kind of what I was talking about in terms of skipping steps. If I think to myself, what is the square root of 4? I know that that is going to be 2. And I'm left with root 7. Then I'm going to subtract. I take the square root of 100. I get 10, root 3. And then square root of 4 is 2, root 3. I didn't do the 27. Let's break down the 27 into 9 and 3. So this is 3 root 3 plus 2 root 7 minus 10 root 3 minus 2 root 3. Sorry about that. Could have done it all in one step. Is one prime number? Yep. 1, 2, 3, 5, 7, 9. All primes. The definition of a prime number is a number that's only divisible by itself and 1. And because 1 is divisible by itself and 1 happen to both be the same thing, it's technically a prime. 2 is kind of the strange prime because all even numbers are not prime with the exception of 2. It's a bit of a different one. All right, once I get here, I need to combine like terms. So 3 root 3, 10 root 3, 2 root 3. I'm going to combine those all together. So 3 minus 10 is negative 7, minus 2 is negative 9 root 3. And then I have this 2 root 7 that I can't get rid of or combine with anything else. Again, I could write it the other way, 2 root 7 minus 9 root 3. Both are the same thing. 1e. Up above here, Taylor. Uh, 1e. Here we go. So I have 5 root 6 plus 2 root 10 minus 2 root 10 plus 2 root 6. I combine my like terms. In this case, I have 5 root 6s and another 2. I have 2 root 10s, and then I'm taking away 2 root 10s. So what am I left with? Turns out that the root 10s just end up going away because I have 2 of them and then I take 2 away. So they're just gone, which is kind of nice because they disappear and I don't have to worry about them. And then I have 5 and another 2 root 6s, so I have 7 root 6s altogether. These guys here in the middle just equal 0, and I don't need to write down the plus 0 because that's not important. So I just have 7 root 6s. A little bit different when something disappears like that. It just gives you 0. Magic. All right. What other questions did we have? I know there's a few more I need to get to. 1 prime, can do 1e, did that. Something. Evaluating irrationals, 6b, simplifying radicals 2 and 8a. Is that the last one? 4 and 5 and b are perimeters. Let's go with evaluating irrational 6b. Is this the one we're talking about there? Haley, did I get that right? Sorry, 5, 6 up here. 6b, graph the following. Perfect, let's go through that. Using decimal approximations. As soon as you see decimal approximations, it's just telling you to use your calculator to figure out what those are. So if let me try this out again. The first one here is the square root of 75. So my calculator is a little bit different to get the square root. So I go square root of 75, and that equals this 8.66. I'm going to just go with 2 decimal places for now. Hopefully that's going to be enough. So square root of 75, maybe I'll just write it down below, is 8.66. 6 times the square root of 2, I can write it in as 6 times the square root of 2. That gives me 8.48. And then 3 times the square root of 6. Is 7.34. All right, so graph each of these on the number line using decimal approximations. I have 8.6, 8.4, and 7.3. So really everything's kind of close together here. I could put maybe 7, 8 in the middle, and 9, maybe 7.5, 8.5. All right, let's locate these things now on our number line. 75 is 8.6, so I'll put it there, square root of 75. The next one I have is 8.48, which was 6 root 2. Put her there, and 7.34 is going to be 3 root 6, somewhere in there, probably a little further over actually. 7.3, just being picky. There we go. So I've plotted those 3 numbers on the number line. Hopefully that simplifies things a little bit for you. There's a couple others. 6b, simplifying radicals 2 and 8a. Simplifying radicals number 2, and then 8a. I'm just going to get that down there. All right, write the following as product of 2 radicals in many ways as possible. So quickly did a couple of these for you guys just when I assigned them. I did A and B. Maybe we'll do 32. So numbers that multiply to 32. What do we think? 32 divided by like 6, 7. Well, let's go with 32 divided by 2 first. Gives us 16. So 2 and 16. 32 divided by 8. What does that give us? It gives us 4. Are there other ways we can write 32? Other ways, 32, 16, 2. I'm thinking there's probably at least 2 more. Four, maybe not. 32, 4, 5, 6, 8, 12. I'm thinking that's it. I guess 1 and 32 as well. Then it asks to circle the pair where one of them is a perfect square. So this one actually has 2 that are perfect squares. 16 is a perfect square, and 4 is a perfect square. So you could do either one of those, but if you did the 4, you would eventually have to do it another step because the 8 has a 4 in it as well. So that would be 2 steps if you pick the 8 and the 4, whereas if you pick the 2 and the 16, because 16 is the largest perfect square that goes into 32, you can just do 1 step. I'll go down to 8a, and then I see Taylor has asked another question here, so we'll get to that as well. Number 8, I said to not worry about it because we're going to actually talk about that in a couple days, but I'll do it anyways. What the heck, hey? So square root of 52, perfect squares that go into 52. I'm going to try 52, 16, 36 I'm thinking is going to be the biggest. No, 52, 36, no. 52 and 4, let's go with that. So I'm going to write down 4 times 13 is the same thing as 52. I have a to the 6, b to the 3. I'm going to take the square root of the 4, and I'm going to end up with 2 root 13, a to the 6, b to the 3. Now we haven't talked about how to take the square root of exponents yet. But basically, you can think of it this way. If you're taking the square root of an exponent, it kind of works out that you're going to divide it in half. And I'll explain why in a couple days. I'm not really sure why this question's here. So what I'm going to do is I'm going to divide the 6 in half because it's divisible by 2. So I'm going to get 2a to the 3 and then 13b cubed. That's kind of as far as I can take that. You don't know the why yet. That's just how. So take it for what it's worth. If you do get a question like that on the Unit 1 test, I'm thinking there won't be a lot. There might be 1 or 2 in the quiz bank. If you just flag it, I'll give you the mark for it if you've tried it. So just try it and see what you can do. I don't think they'll come up a lot though, but if they do, flag it and I will adjust your mark for you. All right, I think we're almost done. Adding and subtracting radicals C and F. Like terms, adding and subtracting radicals 1. I'm assuming we're going C here and F here. Is that right, Taylor? C and F on number 1? On 2. Simplify each of the following. All right, letter C and F. All right, perfect cubes that go into 108. If I look at my perfect cubes that I have written here, do any of these go into 108? Maybe 27, let's try that. Yes, so I'm going to break this 5 times the cube root of negative 108 into negative 27 times 4. Now the negative can stay with the 4, or you can bring it out, it doesn't really matter. It's not going to change your answer that much, just kind of changes where the negative sign is. 7 times the cube root, 32. I know 8 and 4 gives me 32, so I'm going to go with 8 times 4. I'll show all my steps on this one, and then letter F, I won't show them all. So I'm going to break the radical into 2 different ones. I'm going to go the cube root of negative 27 and the cube root of 4 plus 7 times the cube root of 8 multiplied by the cube root of 4. The cube root of negative 27 is going to give me negative 3 times the cube root of 4. And then cube root of 8 is going to give me 2 times the cube root of 4. Do the multiplication. Negative 15 times the cube root of 4 plus 14 times the cube root of 4. Negative 15, and I'm going to add 14 to it. It's going to give me negative 1, or negative, cube root of 4. The negative, yeah, there you go. So that one's a bit tricky because once you pull the negative out, you end up with the 2 root 4s underneath, and that kind of works out the best that way. So there you go. I'll do letter F over here on the side. 1/3 times the 4th root of 243. This is just a cruel question because you're using the 4th root. But when you kind of look at it, I see that this, I'm likely going to have to add these together. And I see I have a 4th root of 3 here. So I'm going to divide 243 by 3 and see what I end up with. Because I have a feeling it's going to be a number, and it is in this case 81. Now the reason I did that is these questions almost always work out. Like very rarely are you going to have something that doesn't kind of work out in terms of adding these things together. 81, I'm hoping 81 is the cube root of 4. So if I go, or sorry, 3. So 3 times 3 times 3 times 3 gives me 81. So I don't know my 4th roots. I don't have any of them memorized. It was just a guess because I saw that 3 in the second term. So I'm thinking I'm going to end up with 2 terms I'm going to probably add together. So I just kind of took a shot in the dark and it ended up being right. So let's actually do that then. Let's do the math here. 1/3. I know the 4th root of 81 is going to be 3. So 1/3 times 3 times the 4th root of 3 minus the 4th root of 3. Is this even crueler than I thought? The 3 divided by 3, or 3 times a third, just gives me 1 times the 4th root of 3 minus 1 times the 4th root of 3. Does it really equal 0? Did they really do that to you guys in the answer? Three to the 4th is the same as 9 squared. That is the correct statement, and we're going to see why that is today, Alex. That's a good point. So, well, we might not see it right away because we're running kind of low on time here, but we're going to get through a bit of today's lesson. There you go. So that was all your questions. Hopefully that all kind of makes sense. In the course, while I'm on the topic right here, up at the top, I put a new little picture in there because I kind of got bored of signing into my face every day. Can't go wrong with a little puppy, hey? It's nice. Puppy chasing tennis balls. But just below that, I put in, I'm available for help. So what we can do is just kind of like we do, or you guys do with Mrs. Wood in Blackboard. You guys just log in, and what I can do is I can hook up my laptop to Blackboard, and I can talk, and if you want to talk, you can talk back to me, and you can ask questions, and I can go through problems with you. You can just type them into chat. The only problem we run into is that I teach another class, and it kind of alternates in the afternoon which block it's in. So some days I'm available from like 12:30 to 2, and then some days I'm available from 2 to 3:30. So if you're kind of stuck on a question, a lot of you have been just sending me emails or messages in Moodle asking questions. If you're kind of stuck on something and you just want to meet in Blackboard for like 10 minutes or like half an hour or whatever until you get all your questions out of the way, just fire me a message and I'll just tell you when I'm available, and then hopefully you're available as well. On the odd day, I can stick around for a little bit after 3:30 and I could help you then. I'm usually here till about 4 most days. But the best bet is just to send me a message and say, hey, can I get a little bit of help? And wondering what time you're available this afternoon. Some days I have meetings, and most days I don't, though, so I can definitely make time for you guys. So there's kind of 2 time slots in the afternoon. My other class flips back and forth depending on the day. So we can make a go of it, hopefully, if you have any problems. And any other way you can contact me out. I'll help you out. Usually I don't answer emails after about 4 o'clock. I go home, spend time with my family. So if you're doing things late in the evening, I probably won't get to it until the next morning. If that makes sense. So hopefully that helps. If you guys do have questions or you want a little bit of extra help with these things, or maybe cleaning up some of the stuff from Unit 2, that will be available for you. Does anybody have any questions about Unit 1 in general, the test, timeline, sort of time frame, anything along those lines? Anything I haven't gone through, kind of confused about? I just want to kind of put Unit 1 to bed here and get you guys going. So the next unit is Unit 3, and we're dealing with exponents, and it kind of has a little bit to do with the unit we just finished. There you go. Ava's asked a question. What about midterms? And do we need to do the test by today or tomorrow? Both good questions. Midterms, I'm thinking the first midterm will be on November 9th. We're just trying to finalize the day because we need to book the gym over at Central. We'll likely be in there in the morning. So Mrs. Wood was arranging that for me, and I'm thinking it's November 9th for sure. So November 9th is the probably going to be the midterm. All you're going to need to bring is a pencil and a calculator, or a pen and a calculator, whatever you want. It'll just be you guys. Yeah, it'll be the gym at Central and just you guys in there. I booked it all out. And you just show up. There'll be a midterm online, so I'll have the school computers there because they connect to the school network a little bit better. And then there'll be a written section. Now, typically the course has the written section kind of built into Moodle. And it's a lot of work because you have to put in equations and things like that. So you spend more time learning how to write in equations than actually doing the work. So I'm thinking I'm going to have the multiple choice section will be on the computer, and then I'll have just like a paper written section. I'll have like 5 or 10 questions on it for you guys to go through. It'll be all the 3 units that we did at the beginning. So unit 1, 2, and 3. And I don't know if we'll have unit 4. Taylor, I know you're out of town. It's a good point. If you're out of town, we can we'll figure something out. So I don't really want to talk about midterms yet because I'm still finalizing everything for sure, how many questions, what's going to look like, where it's going to be. And for those of you who are out of town that week, where you're going to go to write it. So like I know Taylor, you're in Vancouver usually, so we will either arrange something near you or we'll figure something out for you to do that. Do we need to do the test by today or tomorrow was the next question. If you can get it done by the end of the day on Friday, I would be more than happy with that. And, like Friday, you have the whole day off because it's a professional development day for the teachers, so there's no field trip on Friday. But if you want to do it before then, perfect. Abby said if you get it in today, yeah, definitely. I will be in my office till about 4 o'clock today. So if you can get me a review before then, I would be happy to have a look through it and then get you guys the password for that test. And in terms of the next unit, I only have 5 minutes left or maybe 15, but I'm not going to jump into unit 3 because I think we're probably pretty good there. So the what we'll do next day is we'll maybe just zip through unit 3 real quick because it's the first lesson. It's stuff you've done already from grade 9. And then we can move on to maybe get like a couple of the sections done next day. Because we have it in the morning, so it'll be an hour and a half class, or hour and 20. It'll give me a little bit of extra time. And I won't have any questions to go over because you guys are all masters at unit 1 now, which is very exciting. And the quiz scores for the first quiz in Unit 1 have all come back pretty good. And a few of you have written the second quiz from Unit 1. I would like a few more people to get that done. And then I'll send off the password to you guys when you get that review in. So I'm thinking I'm just going to end it there for today. I don't want to get the next unit going. Does anybody have any further questions about midterms or, test, Unit 1, Unit 2 stuff? I sent you a few of you messages in Moodle on getting the Unit 2 stuff kind of finished up. I know a few people missed one of the quizzes in there, and it'd be really great if you go back and just polish that off. I'm still waiting on a couple reviews from Unit 2 so we can get that test out of the way for a few of you, but generally speaking, we are maintaining a pretty good sort of pace. We're maybe 1 or 2 classes behind where I'd like to be. So maybe a few of the easier sections we'll kind of breeze through coming up here to get us caught up a little bit further. That's just kind of it for now. So I don't see anybody typing questions in. And hopefully you guys have any questions that come up between now and the end of the day, send me a message in Moodle. So I'm just going to leave you guys there. Good luck with the second quiz in Unit 2. Get that learning guide in, second quiz in Unit 1, get the learning guide in for Unit 1, and we can get that test done. It's 20 questions, but a lot less material for this unit, so the test should be a little bit simpler than the Unit 2 one. Thanks, guys. We'll see you tomorrow morning.